Difference between TCP/IP and OSI model. TCP/IP. Transmission Control Protocol/Internet Protocol. The most widely used communications protocol, TCP/IP prepares and forwards data packets over a network. OSI. Open Systems Interconnection. The OSI model is a conceptual model that characterizes and standardizes the communication functions of a computing system. Application layer, responsible for providing services to the user. Presentation layer, take care of syntax and semantics of the information exchange between two communication systems. Session layer, it establish, maintain, synchronize, and terminate the interaction between sender and receiver. Transport layer, responsible for process-to-process delivery. Network layer, responsible for delivery of individual packet from source to destination. Data link layer, responsible for moving frame from one hop to next hop. Physical layer, responsible for moving individual bits from one device to the next device. What is physical layer? The physical layer is the foundational, bottommost layer, layer 1, of the OSI model, responsible for the physical connection between devices and the transmission of raw bit streams, 1S and 0S, over a communication medium. It defines the electrical, mechanical, and functional specifications for the hardware, such as cables, connectors, and interfaces, and specifies how these raw bits are converted into signals, electrical, optical, or radio, and transmitted across the network medium, like copper wires or fiber optics. What is data link layer? Network security. The data link layer is the second layer of the OSI model and is responsible for reliable, no-to-no data transfer between devices on a local network by packaging bits into frames, handling addressing, like MAC addresses, and ensuring error-free and efficient data transmission through flow and access control. It receives data from the network layer, converts it into a physical layer-compatible format called a data frame, and passes it to the physical layer for transmission. What is network layer? The network layer is the third layer, layer 3, in the OSI model, responsible for logical addressing, routing, and forwarding data packets across different networks to ensure end-to-end communication between devices. It works by assigning unique logical addresses, like IP addresses, to devices and determining the best physical path for data to reach its destination, using protocols such as the Internet Protocol, IP. What is transport layer? The transport layer is the fourth layer of the OSI model and the second in the TCP/IP model, responsible for establishing and managing end-to-end communication between application processes on different hosts. Key functions include data segmentation, flow control, error control, like retransmission, and multiplexing/demultiplexing data using port numbers, all to ensure reliable and ordered delivery of data across a network. Common protocols at this layer are TCP, which is connection-oriented and reliable, and UDP, which is connectionless and faster but less reliable. What is session layer? The session layer is the fifth layer of the OSI model, responsible for establishing, managing, and terminating communication sessions between application processes on different hosts. It synchronizes data exchange, controls the flow of dialogue, and recovers from interruptions by using checkpoints. Key functions include managing the session lifecycle, establishment, maintenance, and termination, coordinating dialogue control, and providing recovery services, ensuring efficient and reliable communication for network applications. What is presentation layer? The presentation layer is the sixth layer of the OSI model, acting as a translator and intermediary for data between the application and network. Its primary functions include data formatting and translation, like character code conversions, encryption and decryption to secure data, and data compression and decompression to reduce file sizes for efficient transmission. This ensures that data from one system can be understood and used by the application layer of another system, regardless of their differing architectures. What is application layer? The application layer is the top layer, layer 7, of the OSI model and provides an interface between user applications and the network. It uses protocols like HTTP, FTP, and SMTP to enable services like web browsing, file transfers, and email, allowing users to interact with network services and access data. This layer handles tasks such as data conversion, network management, and ensures that data is presented in a user-understandable format. Layered stack. Application layer. Transport layer. Network layer. Data link layer MAC/LLC. Physical layer. Basic functions. Compression and error concealment. End-to-end error recovery, retransmissions, and flow control. Neighbor discovery, routing and resource allocation. Channel access, error recovery, retransmissions, and queue management. Modulation, coding, power control, and mobility status. Encapsulation versus decapsulation. Encapsulation. Process, adding headers, and sometimes trailers, to data as it moves down the layers of the OSI or TCP IP model, from application to physical layer. Direction, sender side, top bottom. Purpose, prepares the data for transmission by attaching necessary control information like source/destination IP, port numbers, others. Example, when sending an email, the message, data, is wrapped with transport, network, and data link headers. Decapsulation. Process, removing headers and trailers from data as it moves up the layers of the OSI or TCP IP model, from physical to application layer. Direction, receiver side, bottom top. Purpose, interprets and extracts the original data by stripping off each layer's control information. Example, when receiving an email, the system removes the network and transport headers until only the actual email content is left for application. Difference between MTU and MSS. MTU. Maximum transmission unit is the largest size of a packet or frame that can be transmitted over a network. Scope refers to the entire packet, including all headers and data. MSS. Maximum segment size is the largest amount of data, excluding headers, that can be sent in a TCP segment. Scope refers specifically to the data portion of a TCP segment. In short, encapsulation equals wrapping data with headers, sending side. Decapsulation equals unwrapping data by removing headers.